We're going to talk about Florida Best Mathematics, Grade 8, Geometric Reasoning 1.1 and 1.2. 1.1 states apply the Pythagorean theorem to solve mathematical and real-world problems involving unknown side lengths in right triangles. So as we know, the Pythagorean theorem states a squared plus b squared equals c squared. Now, some students will struggle with identifying A, B, and C on your right triangle. We're going to scroll down here. I'm going to draw one real quick. There's our right angle. And then it doesn't matter which side adjacent to the 90 is your A and which is B. Both of them are legs. Leg, leg. And then C is always your hypotenuse, which is always across from the 90-degree angle. Once you have identified the sides of the triangle, then you, instead of writing a squared plus b squared equals c squared, can write leg squared plus leg squared equals hypotenuse squared, right? But you should signify leg A or leg B or leg 1 or leg 2 or something when you use your formula. But essentially, what you're going to get out of this is you're going to get hypotenuse is equal to, remember, the hypotenuse squared is in the Pythagorean theorem, so we need to take the square root of both sides. So the hypotenuse itself is going to be equal to the square root of leg A squared plus leg B squared. And then the other equation you're going to get out of it, I'm just going to put leg equals the square root of the hypotenuse squared minus the other leg squared. Oh, squared's up here. So either you have leg A or leg B, one of them is going to be unknown. So obviously the unknown is going to be the one here. And then the known one is going to be here in the equation. So one of these two equations is what you're going to use to solve these problems. Now let's go over to Delta Math, and we can take a look at one of these problems. So we have, in the search bar, we typed in Pythagorean, and then we can select a rounding problem or a simplest radical form problem for your answer. So let's just go with a rounding problem. Find the length of the third side. Okay, so what do we have? We have three sides, one unknown, right? Which one's the hypotenuse? Across from the 90, so there's our hypotenuse is 16. And then let's say leg 1 is 8, and leg 2 is our unknown, our x. So what we're going to use is this second one here. Leg equals square root of hypotenuse squared minus our known leg squared. So all we have to do is click on our calculator button. Here's our calculator, and hit square root of our hypotenuse, 16 squared. Here's a squared. Okay, and then minus our known leg squared, 8 squared. And then it says our answer here. And see how it says in the problem, if necessary, round to the nearest tenth. So the tenth is going to be the first number after the decimal. That's our tenth, and then our hundredth. So our hundredth place is a 5. So that means we are rounding up. Because it's 5 or higher, we round up. So we have 13.9. So we put our answer, 13.9, and submit. Okay, now let's go back, and we're going to do a coordinate distance problem with rounding. Okay, so on these problems, this is essentially going to be using the Pythagorean theorem to find the distance of the hypotenuse, which is going to be between 2 points on a coordinate plane. So you're using the distance formula. We're going to as the problem instructs, create a right triangle. Graph a right triangle with the 2 points. So you can either go down or you can go right. So we're going to try going right. And then we're going to go down from here. There's our right triangle. And then we need to identify the leg lengths. Now this is the part where it's similar to the distance formula, because the distance formula will have you take the coordinate values and subtract, right? So if I subtract and I say, well, what is -2 minus -7? -2 minus -7, that minus a negative is going to change to plus positive, and we're going to have -2 plus +7, which is going to give us a value of 5. But it's also going to be the same as the number of squares we can count, 1, 2, 3, 4, 5. So leg 1, it doesn't really matter the order for legs, so let's put 5. Leg 2, 1, 2, 3, 4, 5, 6. So leg 2 is 6. And if you want to confirm that by crunching the numbers, we have a -9 and a -3.
So -9 minus -3 is -6, but distance will never be negative. So
there's our +6. Now for the distance, we need to use the calculator again. Here's our calculator. And we're going to type in leg 1 squared plus leg 2 squared. This one. Leg A squared plus leg B squared. So we're going to do 5, the square root of 5 squared, plus 6 squared. Oh, I did a to the b, so I need to put a 2 in here so that it's still squared. And our answer is 7.81. Round to the nearest tenth, so it's going to be 7.8. And there you have it. Now, when it says apply the Pythagorean theorem to solve mathematical problems, that's what we just did. Now, real-world problems is another way of saying word problems, so here you go. The area of a rectangle is 209 square units. Its width measures 19 units. Find the length of its diagonal. Round to the nearest tenth of a unit. So the first thing you want to do is draw this out. Let's get our space back. I think we can draw it here. We have enough room. So we have our rectangle. And it said the width is 19 units. So I'm going to put 19. And the area equals 209. Okay, so area of a rectangle equals length times width. Okay, so if this is the width, 19 width, then this is our length, and we don't know what it is. Okay, so 19 multiplied by x equals what? Length times width equals area. Area equals 209. 209. So then all we need to do is divide both sides by 19. Divide by 19. And we can put that in the calculator here. (209) divided by 19, and that gives us 11. Okay, but is that our answer? It says find the length of its diagonal. Okay, so let's go back to our drawing. Okay, so we have an 11 here for x. But what we need is the length of this diagonal? Well, that's where we use our Pythagorean theorem. Okay, we have two legs of the triangle that is formed here. This is a right triangle because a rectangle has four right angles. Okay, so all we have to do is use the equation that works for us. So, we were down here. Which one of these equations is going to work when we're solving for the hypotenuse? This one. Hypotenuse equals the square root of leg 1 squared plus leg 2 squared. Leg a squared plus leg b squared. So we go back here, and we go back to our calculator, and we type in square root of 11 squared plus 19 squared. And our answer is 21.95. And again, that 5 is going to make that 9 round up, so we're going to get 22.0 for 1/10 of a unit. There you have it. Hope that was helpful.